Absolute minima and absolute maxima. So if we look at a graph, such as this one, we see that there is no absolute max or min because our graph continues in both directions indefinitely. However, we do have a local max and a local min. If we look at this graph of a parabola, this will have an absolute max. It does not have a local min. In this graph, we have an absolute min, but no local max. So what can happen is, or what we can do, is we can close an interval, and then we can have both an absolute max and an absolute min. So for instance, this graph here, on the closed interval from 2 to 12, we have an absolute max, and we have an absolute min, which happens to be the endpoint. If we take and close the interval from 4 to 10, our absolute max is shifted along with our absolute min. Close the interval even more, and we have shifted absolute min, absolute max. We can have more than one absolute max and more than one absolute min. So how do we locate these? To find our absolute max and absolute min, you first have to have that closed interval in a continuous graph. You find your critical numbers, just like we did before, by taking the first derivative, and then you find the values at each of the endpoints and the critical values as long as they are within the interval. So let's look at an example. Find the absolute max, absolute min of this function. So the first thing we're going to do is find our critical values, which is to find the first derivative and where the first derivative is equal to 0. Oops. X plus 3. So our critical values are -3 and 1. So then we look at our two endpoints. The values of the original function are two endpoints, and our critical values if they lie within the interval. And -3 and 1 both lie within the interval -6, 4. You just find the values of those by substituting them into the original function. And then you just look at the values, what value is the smallest value. Oh, my highlighter doesn't want to work. So this would be our min, and this would be our max. say the interval is -4 to 2. -3 is in that interval. 1 is in that interval. So the function evaluated at -4 is 13, -5. And now you can see how our absolute max has shifted, and our min. And then the last one, -3 is not in this interval, 1 is. So this is our max and our min. Okay, so you try match problem number 1, and I'll let it rest on here for just a few seconds so that you can see the problems